All right, hello, everybody. Can you all hear me all right?
Yes, we can hear you.
Thanks, Alyssa.
I hear you.
It's a new laptop, so I just wanted to check if the microphone was working well. All right, so we're at the scheduled time, but I think we should allow, and I see at least we've got, I think, both the presenters, but we should allow a few more minutes for people to trickle in before we get started properly. In the meantime, I'm going to send out our usual call for a note taker, which, as always, we need for this session.
I can volunteer to take notes. It's Watson.
Thank you, Watson. Very much appreciated. That'll save us some time a little later. All right, so let's get started. Thanks, everybody, for joining us. So, so today is another MIMI interim session, and this time, in keeping with our sort of alternating topics, we're going to be focused once again on the user discovery question. All right, so first off, as usual, we would ask that everyone note well the note well, which is IETF's policies for governing meetings, including intellectual property and respect for all your fellow participants. So if you haven't before, please go take a look at all of these documents on the data tracker. Next, we already have a note taker. Thank you very much again to Watson. And now let's talk about today's agenda. So obviously we're going to do the chair slides. We're going to do a quick recap of the discussion on discovery that we've had so far, which has been focused on requirements, just to set some basic sort of definitions and ideas in common that we can all bear in mind as we go through today's presentations, which are focused on particular solution proposals. And then we'll get into those, first Giles and Femi, and then Jonathan. And then I suspect between those presentations and the mic line for them, that'll take up all the time. But if there's any time left over, we can just use it for sort of open discussion on the question of discovery. Okay, so before we move on, any agenda amendments or bashes that anybody would like to bring up? Rowan, go ahead.
Hi, I just wanted to mention that that Andrew Morgan had sent some comments about the content format draft, and we had a short conversation about that, and I finally got around to recover all of my notes from that and write them up, and I just sent that out. So I don't want that on the agenda, but I just encourage people to go take a look at that on the list and to make comments. Those are still some outstanding issues that would be good to close before the the next draft deadline.
Great. We love to see actual activity on the list. Okay. So with that, I'm going to move on to the next agenda item. Let's see. Stop that. Okay. So this will be quick. Again, I just want to recap on some definitions we've settled on so far and sort of a formulation of the problem. As we came to it in the last interim session when we talked about discovery, as well as some discussion on the list that happened since the interim in question, which was back on September 13th. Okay, so first off, a problem statement of discovery. So a service-specific identifier, or SSI, identifies a unique user within a single service provider, and encoded into that SSI is the service provider, which means an SSI on its own can be resolved. An SII, service independent identifier, identifies a unique user, but not in relation to any particular specific service. And it does not encode within itself the necessary information to resolve what service a user might be on. The consensus seems to be that we have to work with SSIs as they already exist in deployed systems, which concretely means E164 phone numbers and email addresses, although not addresses that are necessarily at the domain of any messaging service provider. So you don't get to assume that it's at whatsapp.com or at mycloud.com or something like that. So that constrains our design space. We don't get to sort of invent new formats for SIIs. So user discovery then is the process of resolving an SII for some user into one or possibly several SSIs for that user. Okay, so so that's about it, I think, as far as we got as agreeing on things thus far. And the open questions that we have about discovery, which we should bear in mind as we go through the solution proposals today, are so which actors ought to be trusted authorities for these mappings of SIIs to SSIs? So we've talked a bunch about this notion of certificate authorities in this space and whether or not the service providers would be CAs or would be the exclusive CAs in this ecosystem. Then in the discussion on the list, we interrogated, does this discovery scheme need to scale to tens, hundreds, or thousands of service providers? Excuse me. Then privacy, what is the privacy risks of this discovery system? What might queries reveal about the social graph and to who? Can rate limiting be usefully deployed to prevent scraping of databases? Or if we have a small number of providers, each with potentially billions of users, is rate limiting futile because they have a legitimate need for a huge volume of transactions, of lookups rather. And finally, an SII may map to multiple SSIs if a user has accounts in multiple service providers. So should a requester learn all of them? And how would that work? Would a requester, which could be either a client or a messaging provider, does it hit one service with an SII and get back, with an SII and get back all the SSIs? Or does it have to go query each other service provider that it knows about independently? Or do we punt the problem to a user of an application to have out of band figured out what service provider the other person that they want to talk to is on? Okay, so that's all I had on the open questions and sort of discovery problem statement. Before we move on to our first solution presentation, is there anything else anybody would like to bring up or? Okay. No news is good news. In that case, we can move on to the first presentation on the agenda, which I believe is Femi, or is that your Giles? Are you presenting? Let's see how that goes.
I'll do the presentation. Yeah. Giles is starting, and then I'll follow.
All right, hang on. Let's see. I'll kick my slides off. Stop
I'm not
slide share.
quite sure
Good.
how sharing my slides work. Sorry. Oh, here we go. No. Okay.
And hopefully you'll get buttons in Meet Echo that let you drive it too.
Yeah. Seem to have a.
If not, we have
I
a
do.
version of your slides loaded, and I can drive them for you.
I think I got the right ones. Okay.
There we go. Okay, all yours.
All right. So I'm not going to go over all the requirements that we went over last time, but I didn't quite get to the end of them. So I do want to cover this last set of requirements. So these are really like the non-functional business requirements that I think are super important when selecting a solution here. So first of all, we think that no single entity should be financially responsible for resolving all discovery queries. So that kind of, in my opinion, rules out sort of a single central database and lookup service. And then secondly, sort of related to that, the costs for each entity should be proportional to the number of participating users that they kind of own. And so I think that that makes the costs proportional to the gains, and makes the discovery service kind of economically viable. And then the last one is just a quick sort of performance bound that each discovery service should meet. So we're not expecting a very high QPS here. We're expecting on the order of each client querying approximately once a day, and there will be some heavy caching going on. So yeah, I just wanted to set up those assumptions. Tim, did you want to say something?
Yeah, I just wanted to follow up on that supposition that the QPS would be like once a day per user. That would be a function of how often a user is like initiating a new conversation with somebody, right?
Well, yeah, and how often you want to make sure that your key material is fresh and your account is fresh. Yeah.
Okay, makes sense. Thank you.
Yeah. Okay. So I'm going to skip that slide. So we looked at three possible solutions. One is a client fan out. I'm not going to go into these in too much detail. I'm going to focus on the one that we ended up being our recommended solution. But yeah, we think that the client fan out, where each client just queries the key distribution services of all possible message services that their recipient could be on. It's super expensive in terms of client bandwidth, and it also leaks private information to services that you might not be sending a message to. The second one is the centralized hub. As I already mentioned, it doesn't really meet the economic requirements that we set, and also is kind of politically complicated as well. Like who do you trust to be the message delivery hub, you need a consortium agreement or something, or a contract between them, or somebody who's going to agree to do it, to perform that service. So it creates political complication. So we think this the preferred option is what we're calling a federated resolver service, where basically each, and I'm going to go into the details of it on the next slide, but each service runs their own resolver on the server side, and that is able to fan out and either cache the mappings or query them in real time. And it uses a private information retrieval protocol to avoid leaking the social graph, the queried numbers to the services that are not actually going to be sending messages. Jonathan. Did you have a question?
Yeah, can you hear me?
Yeah.
Okay. A clarifying question, because I think this is sort of the root of some of the disagreements. I want to get it. Could you go back to the prior slide?
Yeah.
I think in your proposal, you are assuming that each of these messaging service providers is directly participating in the resolution process and the discovery process. There is no intermediate discovery provider. Is that correct? No separation.
Yes.
No separation of a provider of discovery distinct from the provider of messaging. Is that correct?
Correct. Yeah.
Okay. All right.
Yeah.
I think
Although I guess they could be. I mean, the resolver service could be not owned by the sending messaging service in this diagram.
right. Okay. And maybe it's related to my next question. In this picture, when you say client, is this like my mobile phone, or does client like a different messaging service?
The client is the mobile phone. Sorry for not being clear about that. Yeah.
Oh, I see. So this is all, I see, interesting. Okay, so you're proposing like the WhatsApp mobile app would be modified to directly talk through this KDS resolver to iMessage, Facebook Messenger, or whatever. That's what this picture is.
It's not really talking through the KDS resolver. What happens is WhatsApp would first reach out to its server-side KDS resolver or some other KDS resolver. The resolver would say, hey, you can find keys and deliver messages on services 1 and 2, but not service 3. And it would just send only that kind of bit mask back to the client. And then the client would say, okay, give me the keys for this user, and then send the message to the user. Or that could be done server side as well, but either way works. But it'll be more clear in the next slide.
Okay, I'll wait.
I think Alyssa had a question as well.
Let's see, unmuting, sorry. Yeah, so I just wanted to raise this question from Conrad because that's in the chat. It also came up on the list. I think there's been a little bit of confusion between the conflation of the key distribution with the finding out the SII to SSI mapping because there's keys that you need for MLS or whatever you're going to use to encrypt the messages. And then there's this mapping question, which is not necessarily the same. So could you just talk a little bit about that so we can kind of level set on when you're talking about key distribution, what does that cover?
Yeah.
Something separate.
Yeah, sorry.
Messaging keys.
Yeah, sorry, I haven't really updated these slides since we kind of settled on the SSI, or since I understood the SSI SII terminology. But basically, it doesn't really matter what these services 1, 2, and 3 do. Like it could be key distribution, message sending, whatever. The resolver just sends you back the mapping, the SSI to SII mapping.
Okay, so
yeah.
the message key distribution could be entirely separate from what you're showing here.
Yeah.
Okay.
In fact, we have updated this diagram, so like
Okay.
basically, yeah. If you go, I don't know, can you see my mouse or?
No, I can't see your mouse.
Okay, so basically everything up to the 5th horizontal arrow is the SSI to SII mapping, and after that, it's using that mapping to get keys and send a message. So the sequence diagram is, first of all, the server for platform 1, which is the client's server side, and these first 2 steps are optional, but the platform can request and cache what I'm calling the name records, which is the mappings. So each platform publishes. It's very similar to DNS, right? Each platform publishes their own mappings for all other participating platforms to retrieve, either out of band or in real time. And then when the client, that means the mobile device, mobile app, wants to get the mapping, it sends a PIR query, private information retrieval query, to their own front end. That means the server side. So WhatsApp client sends a message to WhatsApp backend. The WhatsApp backend then either sends a query to their own cached name server, or directly to the platform 2 name server, and they get back basically this mapping from that. So it's pretty simple up until that point. And then to address some of the very long discussion we had on the mailing list in between, which is great, we then use that bit mask to reach out to the key distribution service. And again, like, this is a separate part of the protocol, to answer your question, Elisa. But for getting keys, we reach out to the key distribution service of the platform that we now know has a user with that SSI. And returns a key bundle, and that key bundle is signed by either the provider themselves. It's not just the key bundle; it's a mapping between the key bundle and the SII. That's signed by the either by the platform, receiving platform themselves, or a third-party certificate authority. And I strongly I'm of the strong opinion that we should not be defining what those CAs, any requirements for those CAs in this specification. I think that should be a separate specification. You get the key bundle and you send the message. I see there's a bunch of questions. So, Tim.
Actually, I answered my own question after reading your slide more carefully. So let's go on to Jonathan. Thanks.
Yeah, hey, so just trying to understand, make sure I understand this. And I think for me, really important to understand what these entities are. Like, I mean, ignore the arrows. Like, I almost don't care. Like, I don't even think we're on the same page about what these entities are. So I'm trying to understand in your model what these entities are and what their relationships are. So let me ask this question. So Platform 1 client is like the WhatsApp mobile app. And Platform 1 front end, that's like the servers run by WhatsApp, right?
Yeah.
Okay. Where I start to get confused is Platform 1 name server. So is that, I thought I heard you say it could be the same as Platform 1. It could be a different independent provider of these services of performing these PR queries. Is that right? Or how, or in this design, is this coupled to being owned by Platform 1, by WhatsApp, for example?
It could be an independent, it could be an independent entity. And it could also not exist at all. It could be that Platform 1 front end reaches out directly in real time to the authoritative name server. And I think that will probably be the most common model, is that there won't be any Platform 1 name server. Because if you imagine, like, let's suppose Platform 2 is WhatsApp and Platform 1 is a much smaller provider. You don't want, and this goes back to the requirement I said at the beginning, you don't want Platform 1 to have to retrieve, synchronize, and cache the entire database of WhatsApp when it only has 10 million users. Right. So WhatsApp has, I don't know, 3 billion users. I don't know what the number is, but so we don't want to force any entity to cache not only WhatsApp but every other large provider in the system, right?
Okay.
Does that make sense?
Right.
Yeah.
Yeah, it does. I think it's good too, because this picture at least is much closer to the GLaDOS picture. So I'm trying to understand what's different and whether or not your proposal was like fundamentally in opposition to the idea of a discovery provider being distinct from the application provider. And what I'm seeing in this, and previously it was, but in this it's not. So that means, I hear what you're saying is sometimes it is, sometimes it isn't the same as the application provider. Is that right?
Yeah.
Okay, thank you.
And the KDS and client, is that clear? Hopefully, what those are. Key distribution service. Alyssa.
So just one more question on this, and then I have a separate question, which is that what it sounds like is that your first two arrows there, that exchange is it's basically optional for a platform that wants to cache the records of a certain other platform. So a given platform might take this step for some interoperating other services and not for others, or not at all. It's totally optional, and it's decided on a pairwise platform basis. I can cache these records.
Exactly. Pairwise.
The whole point is just to have the records cached.
Yeah, it's not just Platform 1, but also Platform 2 has to agree because of rate limiting, etc. Yeah.
Okay. So then my other point of clarification is the first 5 arrows here consist of the discovery phase. And then from then on, we're just talking about generic MIMI, whatever that means, like once the requesting platform has the identity, the SSI for the other service that it's interoperating with, from then on, we just bootstrap a communication in the same way as if you never went through this discovery process. Like if platform one client came into its interaction already knowing what the SSI was for the user on the other end, you would just proceed with the bottom half of this this diagram according to however we decide that MIMI works. In other words, there's nothing tying these two halves together, or am I missing something?
No, you're right. But my understanding was we wanted to do, in this subgroup, we wanted to do discovery and identity, and the 6th and 7th arrows are important for, establishing trust in identity, because you have somebody's vouching for the mapping between the key and the identity. Yeah.
Okay, so this is your proposal for how to do that. Okay, I got it. Thank you.
Yeah, my very simple proposal. Yeah. Yeah. Eric, I do have another couple of slides, by the way. But
Hi, Josh. Thanks. Sorry, I conflict a little earlier, so I may have missed it when you said this, but I guess I'm not quite sure I'm following.
I'm sorry, you're really quiet.
Oh, okay.
That's better, I think.
Okay. So I guess I'm not quite following what role PIR is playing here, which is to say that as I read this diagram, platform one is very quickly going to learn who the user is talking to as soon as the user requests the keys. And the only person that PIR is concealing that information from is platform one. So I don't quite understand what PIR is doing here.
Yeah, I think that might be a missing point here, is that the request for the keys is tunneled through platform one.
But I guess maybe I just confused out what we're trying to do, which is like we're trying to conceal from platform one that his user is talking to a specific person on platform two. That's part of the design, as a design constraint.
We're also trying to. I think the main point is trying to conceal from platform two if platform two is not a platform that you're about to send a message to.
No, okay, that I'm on board with. But then what is the PIR doing? Because this is only going to platform one's name server. That's the part I don't understand. Like, if it was going to platform two, I totally get that. But like, it's only like.
Yeah, I think that's a mistake in the diagram.
Oh, okay, good. And we're on the same page.
Well,
thank you.
I think the point is, if the name records are cached by platform one, then platform one also needs to. Well, sorry, if they're not cached, cached, then
you need PIR. Yeah. So I think let me see if I can restate the design requirement, which is that the pair of platforms that will actually be used for the conversation become aware of who's talking, but platforms that are not involved in the conversation and do not have a record for the user do not become aware of who's talking. Is that a fair design?
Yes, exactly.
Perfect. Yeah. I'm on board with that, and I think I understand how you're trying to do it. Thank you.
Great. Yeah. I think we need to update the diagram. It's not very clear from that. Yeah.
Just one more thing on that. Just for clarification, so that means that the initial PIR query, you don't need the initial query to use PIR if the name records are cached. Was that when you were saying there was an error on the slide?
I think so. I have to think it through, but yeah, I think that's right.
Okay.
Yeah, so just a quick thought. Yeah. So in some
the model we are looking at is on your device, you have multiple phone numbers or service independent identifiers. You have multiple services that you use, WhatsApp, you can have messages, different services. So from the perspective of your client, you really don't want a single name server to learn your social graph completely. So in a sense, it could make sense to use PIR for that stage.
Yeah. Yeah, I guess that, yeah, that applies to a cached name server and a destination of a name server that doesn't know that you're not going to send a message to. Does that make sense? Anyway, we'll make sure it's clearer. Watson.
Hello, Watson Ladd. So I have a question about where does key transparency fit into this? Is that something we'll put in with the public key bundles coming from the platform to KDS?
Well, I think that would be a separate service. So, yeah, I mean, I should have numbered the steps, but steps 6 and 7 are the key distribution part. But if you want to have a kind of independent ledger somewhere else that you check against that assertion, that would be yet another query that you make to a different service. Does that make sense? So it's not, none of this includes a CT-like service that like WhatsApp has just launched. I don't know if you saw that. Okay.
Makes that clear things up.
Say again.
Thanks. Clears things up.
Okay, great. Tim?
Thanks. So I'm curious how this works in the setting where there are multiple SSIs for an SII. My reading of this sequence diagram is that effectively platform one front end, supposing platform one front end had multiple cached records for the SII mapping to different SSIs across different service providers. Does platform one front end get to choose on behalf of the client which other platform it's going to select?
That's the next slide.
Okay. And yeah, and I'm also curious because I saw there's the mention on your slide about like default service and preferred service, and that seems like a consideration that like is a higher level than an individual SII to SSI mapping. So I'm curious, like, how does a client ever express that, and where is it stored? Because it feels like it doesn't belong in an individual service provider's SII to SSI mapping. But I'll let you present this slide.
Yeah, so I think it does. I mean, I'm not sure how to deal with. I'm not sure we thought through like how to deal with conflicts where two different name servers claim that they're both the preferred service. But I think we're assuming that they're all kind of honest, and in that case, basically there would be a bit on the name on the mapping that says that this service is the preferred service for this user. Right, and that would have to be, you don't want anyone to be able to hijack that preferred service bit because it could be an attack vector as well. And so the proposal is that that bit is signed with the private key, with the user's private key, and then you verify it on the sender side before you decide to select that one. Yeah. So yeah. Conrad?
Yeah, maybe we should skip this discussion and continue with the discovery part, but I have questions on the identity part, and you noted that the identity might be bound to the SII by the CA. And so I'm wondering how that works. And this is also kind of, I'm thinking with the mechanics that you just described, where you're looking at a signature by the client over who is the default provider. But if you get the signature only by actually, like, what key are we talking about? And don't you get that key only after, like, isn't that would be a provider specific key, no? And so which provider's key would it be? And so, yeah, and also, you know, if a phone number or an SII changes, then I'm just kind of curious about the whole mechanics of binding, of how the providers bind how the SII is bound to the SSI cryptographically, and if one of them changes, how does that work, and how do clients manage that? But maybe we should perhaps go discovery first. Like, feel free to, not answer.
Well, I can do a quick answer. Is that you seem to be saying there's a bit of a chicken and an egg problem, but I don't think there is, because this selection happens at the point where you know there's a set of services that have an SII for this SSI. So you've got the full set of mappings, and you just want to know which one of those is the user's preferred one. And so you could go and get the keys for all of them, and then verify which one is the preferred one. And I don't think there's a chicken and egg problem there.
Sure. Okay, fair enough.
It's only your trust in the preferred service bit that's at stake here, and not your trust in the mapping at this point. And the mapping is asserted by the service provider as CA model, right? Or a third-party CA, like whatever. Basically, whatever response you get to, like in Arrow 7, return public key bundle, that is the kind of identity assertion.
Yeah, I'd also be interested in how does it work if an SII changes, and then, do you have to re-pick up all the assertions? Do you have to do the whole recovery? Or if an SSI changes, vice versa, how the whole identity binding system works?
Yeah. That's where the requirement I set out at the beginning of, like, how often do you want to refresh this before you send a message? Obviously you can't do it before every message, probably. So I think it's a trade-off between between the cost of doing this query and how fresh the mapping is. But basically you have to re-perform the query. There's not going to be any push mechanism available. Yeah.
Okay.
Yeah.
Right. Thanks.
Eric.
Can you go ahead to the next slide? Because I think I'm not quite sure I'm following. So is the concern here that I have an account with the recipient has an account with service A and service B, and he actually prefer to receive message on A, but B asserts that he would like to receive message on B?
Yes, and also, like, kind of worse than that is Meatbag A has an account with SSI 1 with a service A. Meatbag B has an account with SSI 1 with service B, and Meatbag B is an attacker who asserts that the preferred service of Meatbag A is service B. So like basically they get you to send a message to an attacker could get you to send a message to them when you think you're sending a message to somebody else. We've got it in our proposal. You can look at the steps. I know it's kind of hard to explain.
Okay, I can take a look, but I feel like you've lost me because I can just inherently speaking, like we have like a E164 number, and that corresponds to like is the original number is the SII, right? And
yeah, but we're not only talking about phone numbers here, right? We're also talking about arbitrary strings that don't have proof of possession attached to them. Like a phone number is different because only one meatbag can own a phone number.
Well, but I guess even with the phone number, the problem exists because we have two services, each of which assert that they have a user with that phone number. Like so, I type in your phone number, and you are somehow and the attacker is somehow persuaded, WhatsApp to assert that it has a user with that phone number. There's like no way to distinguish those cases, like without an external CA, right? Like if you and I, if you actually have an account with Google that corresponds to your phone number, but WhatsApp is screwed up and they've given somebody else an account with your phone number, like those are symmetrical positions.
Yeah, I mean, I guess
if there is proper authentication, it will be quite difficult to give your phone number as an account in WhatsApp, right?
Well, but I mean, but I guess that's what I'm trying to understand is the hypothesis that the attacker actually is willing to represent a phone number they don't own, or is it they're not? If they aren't, this problem is very easy. If they are, I don't see how to solve it without like a central search method of CA, right? Because there's like no sense in which WhatsApp's assertions are superior to Google's assertions.
Yeah, I have to think about that one some more. You might be right. Maybe this is not necessary.
I mean, so to be clear, I do think we need a mechanism a correctness mechanism, which ensures that the user's representations about which service they wish to receive on are correct. And that means that, as Watson was suggesting, like that if I have a WhatsApp account and an iMessage account, and I tell iMessage I want that to be my default, like I want to receive an iMessage, that shouldn't require WhatsApp to do anything to make iMessage superior, right? But I think that has to rely on me controlling both accounts. And so I think there's a difference between like, as long as WhatsApp is willing. So like, I mean, to give a concrete example, imagine the record you post, which is a signed assertion that I want to receive on this account, and it's got a timestamp. Well, WhatsApp shouldn't generate a new one with a new timestamp unless I push the button again on WhatsApp. But I think that's different from WhatsApp is trying to steal it. I don't say how to solve that.
Yeah, I think what we were thinking is the way to solve it is the only real way to solve that is I have to tell you out of band. Receiver has to tell the sender out of band that they have a WhatsApp and an iMessage account, and if you get a message, or if you are told that I have a Telegram account, it's a lie, right? Jonathan?
Yeah, so I'll repeat my request, I guess, which is our biggest areas of disconnect between these two proposals and the problems in this working group in general are not about the lines in these sequence diagrams, but what these entities are and what their cardinalities are. So that's why all my questions are always going to be about that, because we're just not on the same page yet. I'm trying to get us there. In this picture, you've introduced two new entities, a service UI and a resolver. I don't know what those are. Who are those? Can you give me map it to an example? Is resolver WhatsApp back? Those two names were not in your previous diagram.
Yeah, sorry.
Are these new components of the same actors, and what are their cardinalities, please?
Yeah, sorry, we're a bit sloppy here. Yeah, so the service UI means WhatsApp backend, and the resolver is the let's go back to the previous diagram. Sorry. So the service UI means platform one front end. It's basically like everything owned by WhatsApp, where the sender would, the recipient would register their account and their preference, and and then the resolver is actually, sorry, it's platform 2 name server, right? Service UI is platform 2 name server. So it's like, it's where I register my preference.
Okay.
Yeah, and then the resolver is either platform 1 front end or platform 1 name server, depending on whether you have an independent name server.
Okay, where it would be helpful to try and put it in those terms, but I think there's a cardinality problem, and I think it's similar to the issue Ecker was talking about, which is, I think we have a requirement that I, as a consumer, can have multiple messaging applications. I certainly do. I don't know about you. I like one of everything pretty much on my phone. And by the way, you all do mobile number verification with all of them. So the number of providers that I work with that use my mobile number as the SII is also a cardinality of greater than 1. So I think we're also solving for that case. So when you want to register a preference between a set of providers, and I am a consumer of multiple providers, to which one do I register that preference?
Well, like I said at the beginning, we assume that the registering party is handling the uniqueness of their preference. So I'm not, as Jonathan, I'm not gonna set a preferred service bit on more than one service provider.
So I think that's an important requirement. I don't think that works, and it doesn't work for the same reason it didn't work in like the mobile number porting use case. Like if you look at that too, which is like, hey, I want to change, it's always the receiving provider that does the work, and you have to depend on the original. And let me put it in concrete terms. Like, let's say I used WhatsApp for a while, and I set it as my preferred provider. And then I lost my phone, I got rid of it, I forgot my password, and I even forgot I ever used WhatsApp. And then I go and I get Facebook Messenger, and I love that, and I set it as my preferred provider. I literally don't have the password, I don't have anything, I don't have any way to go and remove that from that previous provider. So I don't think you can assume that a user, an end consumer, is accountable for ensuring that this piece of information exists in one and only one place at all points in time. I do not think we can make that assumption.
Yeah, but I also don't think we should have we should spin up a central service just to deal with this. I mean, we have to think about it more, but I mean, you could attach a timestamp and take the latest timestamp to resolve that problem. Eric.
Yeah, Giles, I was just going to say what you exactly just said, which is like the way to solve this problem is that every time you register as a preferred provider, you timestamp that registration, and then you, as part of this thing, you collect all the list, and then you like the one with the greatest timestamp. And as long as you trust the services not to like generate fake timestamps that are newer, which they're not supposed to do, this will totally work. So
Yeah.
I think that problem I think is entirely solvable.
Okay, yeah. So we should add that to the design. Thanks. Great point. All right. We have some more slides about the private PIR of the queries. I don't know. Should we go through those real quick as well?
Yeah, I think
But-
that would be helpful, given that we
Yeah.
spoke about it earlier.
Yeah. So Femi, take it away. I'll drive. Just tell me when to move the slides. I can't hear you, Femi. I don't know if others can.
Can you hear me now?
Yeah.
Okay, thank you. So the approach we are proposing to hide the user social graph, in particular, in many of these discovery scenarios, a user will hold a sensitive SSI or SII and will not want the server to learn exactly what those SSI is. So PIR is a basic primitive, cryptographic primitive that we can use to preserve user privacy in all of those scenarios. So, but for this deck, we're just going to see how we propose the use of PIR to prevent the leakage of the user social graph. The scenario we have in mind is a user can do point lookup by looking up a specific SSI, or the user might do it in bash. Just plug your phone overnight and download all the key materials that I will need to communicate end-to-end encrypted way with all my contact. So those are the two types of scenarios we are looking at. So PIR is a very well-developed area of study. It hasn't been widely applicable in the past, but there are more recent development that we think make it a very good fit to solving this problem. Next slide. So I think I won't go, so I probably don't need to go over this because I went through it all the time, but I can just talk about it very briefly. So the PR scheme that we are really targeting for these are those that based on additive or fully homomorphic encryption scheme. Basically, we can encrypt a value and perform basic arithmetic operations on them while still keeping the result encrypted. Next slide. So for those that are not familiar with PR problem, the problem is simplified as follows. We have a database hem on the left side, and we have a user with an index 4 in this case. That means I want the record at index 4. And I would like to retrieve this record without the database learning that I'm interested in the letter D in this particular case. So how does the user query that in a privacy preserving way, which is the type of problem we are addressing here, which is what PR addresses. So basically the user will represent our query as a bit string that is 0 everywhere except at the index of interest where the bit is set to 1. And then encrypt all the bits individually and then forward the encrypted bit to the server. The server does pairwise multiplication of each of the encrypted bits with the respective database record. As you can see, the result is still encrypted. It doesn't know which of the result contains a value that the user is interested in. And at the end, it sums up all the intermediate result, sends it back to the user, and the user is able to decrypt it to obtain the record of interest. Next slide, please. So the scheme we are proposing is based on lattices, which we can use for all the type of lookups that we are interested in. Basically, it turns any of the standard lattice-based PIR into a keyword-based PIR. Basically, the standard PIR expects that the user knows the index of the record to retrieve. But for this MIMI use case, we know the SSI or the SII. So those are keywords that we will use to privately query the data. So it's a very good fit for it. So it does that by kind of doing an offline process where the database is kind of pre-processed, combined as a linear combination of its record. It also needs the client to store some metadata locally in order to run query more efficiently. There are recent advances in PIR, which is called recursion. Instead, like the example I showed, remember the query we send is linear in the size of the database. So we send an encrypted value for each record in the database, but with compression, we can send two-dimensional recursion. We can send square root of n ciphertext, which is much more efficient. We can even go into higher dimension to a cubic root and even reduce the size of the ciphertext that we need to send. An additional technique that is used is compression and oblivious expansion, which is basically we can compress the query in such a way that we only send a single ciphertext to the server as a query, which is really very efficient. And then the server gets it. The ciphertext that is sent to the server is like an encrypted polynomial, and the server is able to obliviously expand that polynomial into the ciphertext that it will use to process the query. It has great performance that makes it really practical. Next slide, please.
I have a quick question on that slide.
Sure.
How does the client know the full list of records in the database? I think you said that the client has to.
Yes.
Yeah.
There's an client initialization and offline stage where it needs to download some metadata about the database that it will use in subsequent queries. Yes. It's also on the next slide. Yeah.
Okay. Thanks.
So just a little bit more, we have an index-based database. We can convert it into a sparse or keywords-based database. Depending on the size of the database, it needs to be broken up into smaller chunks, which we call shards. And for our experiment on this, we tried for 1 million record database. We think that is a good size to give reasonable performance. So for each shard, we also need to do partitioning and encoding of the database to make query much more efficient. So all the metadata that is required for this, like the shard key, the partition hash key, and the partition boundaries, the client will need to download them at an offline phase prior to running queries. So at query time, the client will interested in the value at value 7 in our database. The client will encrypt a polynomial, just a single ciphertext as we see in this query, and it forwards it to the server. The server does PIR like as before, and returns a response, which is exactly the record that the user is interested in. Next slide.
Oh,
I think there's one more. There's a slide on the number. One more step.
oh, there.
This
This one? Yeah, yeah. I think this is the most important one for this group.
Yes.
Well.
So this is the result of our experiment. We look at 10 billion records, each record of 128 bytes in size, for a total of 1.2 terabyte database. And we split it into 10K shard, each with a million record each. So the number on the right are the performance number for a single shard in the database. So the 40 megabyte is the public key storage that is required on the device. This is an offline thing. It's a one-time process. The user doesn't need to do this download every time. The upload bandwidth is the cost of the query that the client sent to the server. The download bandwidth per query is 21 kilobyte. The time it takes the client to compute the query is just 0.1 second. And for the server to compute the response using just a single thread is just about 1 second. Next. I think that's it.
All right, magic.
Question?
Jonathan?
Hi. I thought I heard something. I want to make sure I understand that there's some need to transfer data ahead of the query. Can you say more about that? Again, because I'll repeat my comment from previous. The main foundational complication in this whole thing is who these entities are, what their business relationships and trust relationships are, and what their cardinalities are. So these are really important considerations, like who's needs to have this information and how many of them are there. So can you say a little more about what is this information that has to be sent ahead of time?
Yeah, so for the client to be able to query a database using these techniques, right, it needs some AirPad data. For example, it needs a hash key to determine which of the shard of the database the query should be directed to. So the client downloads all this LPAR data one time. It's an offline process.
When you say in your model, is client like between providers? So WhatsApp is going to download these shard keys from Facebook Messenger. Is that what you're saying?
No. Client is just the phone, the user's phone.
Okay. Now I'm really confused. I thought I heard
It's
Jill say
same
before.
as Giles mentioned in the previous deck. The
Yeah, but it
client.
was not the phone in his response.
Yeah,
So
it's always the phone.
That's not what he said. So now I don't understand again. That's not what Giles said. Giles said it was the back end. Like WhatsApp servers would be doing this.
No, that was the caching of the name records. This is a different part of the protocol. So that this caching part was not one of my. Sorry, this pre-query step is not part of my diagram.
All right. Is there a picture somewhere that shows between which components this information is transferred?
I don't think we have that in our deck. No.
Yeah. Well,
but
those were the slides that just covered previously with the sequence diagrams.
This one?
Yeah. Mm-hmm.
Which arrow is the pre-cache?
It's not in that diagram, but it would be between arrow 2 and arrow 3, right, Femi?
That would be right, yes.
And it's between which two boxes?
So because the download is offline, in the sense that it's not time critical, so we did not show it here.
Is that like, so what?
Yeah.
Like that is not, no one is bothered that it takes 0.1 seconds versus 0.5 seconds in real time. I'll repeat again, and maybe you don't agree with this, so we should talk about it. I think a really critical problem for us to solve in this working group are, who are these entities? What is their cardinalities? And what is the level of trust we have between them? So it really matters, like if this proposal only works because the WhatsApp UI has to talk to every single messaging provider in the system and download something, like I don't think that's gonna work, and we can talk about why I don't think it's gonna work, but it's certainly very relevant to the protocol. So I do think it's really important, even if it's not in real time. That's what I'm saying. I think it's important, even if it's not in real time. So it will be, can you just elaborate on which components in this picture that download would be between?
So the download will be between the Platform 1 client and Platform 2 KDS.
Okay, and that's, okay, got it. Even though I thought the PIR, I guess where I was confused, and I'll let others come in here. I thought we were talking, like your proposal was a way to formulate the PIR query, which is shown here as arrow 4. So
I don't think that's right for me. Like the KDS query happens after you've already done the PIR query. I think it's between the authoritative name server to platform 2 and the platform 1 client, right?
Oh yeah, yeah. I thought it was referring to the download, right?
Yeah, but the PIR query is on the name server records, not the keys.
Oh yeah,
right.
for this, yeah.
I think we shouldn't try to resolve this question now. I think we should take Jonathan's question and flesh out the answer in our document, and then we can get back to the mailing list with that. It is an important question. I agree. Is that okay, Jonathan?
I think it's super helpful because it, you know, yeah. What are, and then because the trust relationships matter. Right?
Yeah, definitely. Yeah. And also the costs. It's important to understand the costs. Like that query is not small, so yeah. Okay, Eric.
So I think back to I think this question Jonathan's trying to ask goes back to the threat model.
Sorry, you're really quiet again. Sorry.
Okay, this question Jonathan is trying to ask goes back to the threat model, which is, are we trying to conceal from, what are we trying to conceal from who? And there's one model where we're trying to conceal from platform 1 which user the client is interested in. And there's another model where we're trying to conceal, and of course from platform 2. There's another model we're only trying to conceal from platform 2, which user the client is interested in. And in this diagram, you have like an end-to-end PIR between platform 1 and, I mean, so I think that as we discussed, that arrow is supposed to go all the way to the right, but you know, platform 2, this arrow number 4. If we're fine with platform 1 learning what query the user is making, then all the PIR mechanics can go between platform 1 and platform 2, and the user client does not have to be involved at all, right? And that actually, I think, is an important consideration probably for the reasons Jonathan said, which is if this is a system with 50 servers and I have to do a 14 megabyte download for each of them, that's a lot of data, right? Even if it's only one time. And so like I think we really need to get. I think like I'm excited about this PR stuff. I really am, but I think we need to figure out exactly what the threat model is, so we know where the endpoints of the PR apparatus have to be. And I think also, if we can convince ourselves that we don't need to protect the user from his own provider, then this becomes a lot more plausible, because the cost mechanics of the PR are much more easily borne by the provider than by the user's phone.
And I think you're right. We don't need to protect the user from platform one front end, but if platform one, well, if the name server is a secondary name server that is not platform one, then we do. It's not owned by platform one.
Yeah.
But yeah, we'll flesh this out, and we'll put it in the documentation.
Great. I think we should move on to the next one. Appreciate the presentation from both of you. Thanks a lot. I do think, yeah, having the written threat model and a bunch of the clarifications that we talked about today in an updated draft or message to the list from you guys would be super helpful. I also think like just the process of doing the threat modeling, we're going to have to be more specific about who all the actors are and what the trust relationships are between them. And so that would, I think, get to some of the discussion that we were having earlier. And then the only other thing I would just say, because this is a new topic for the working group, I feel like we are many steps removed from like being able to analyze like which PIR and the different flavors and the cost benefit. I mean, the cost benefit is kind of wrapped up in the architecture a little bit, but some of that for this group, I think we're at both an earlier phase, and also like that might not necessarily be our domain of expertise as the locus here. And so we might, want to bring in some other people in CFRG and other parts of the IETF that who can help us kind of sort through that when we get to it, but it's a little bit early on our end. So I just want you to know that, like, it's not that people aren't responding, but that many people here might not really have it in their wheelhouse to be able to compare different PIR schemes and evaluate their pros and cons. So we can take that for a later time. With that, I think we should turn to Jonathan. Thank you.
Thank you.
All right. We're gonna, okay, great. Tim's gonna show the slides. Outstanding. Okay, great. Cool, let's go to the next. Can everyone hear me?
We can hear you.
Okay, great. All right. So I continue to believe that a lot of the disconnect actually lies in our different views on these, basically this slide, actually, the requirements and assumptions, which largely are about the cardinalities, the actors, their cardinalities, and their level of trust. This is why I keep harping on this question. I think if you come to the same point of agreement on that, your protocol choices sort of narrow down and fall to a lot of what I think is in here. So here's the core parts of it. So the first one is that I do believe there is a separation between the application provider and the discovery provider. Those are different entities. They can be the same, but I think they will often not be the same. And that has to do with trust. And that's because in my model, there's a lot of these application providers. Application providers like the guys doing messaging services, the WhatsApp, the Facebook Messenger, but more importantly, and I spent a lot of time on this in the requirements document, I'm interested in solving for cases where these include like business SaaS providers and large enterprises, where you can get into the categories where your messaging providers, people who are implementing the core MIMI protocols, are in the hundreds probably. I don't know about thousands, but it's in the hundreds. So once it's in the hundreds, it no longer, in my view, becomes feasible for those people to act as the discovery providers, and also you just don't trust them. And there's enough use cases where you don't trust many of them. And therefore, I believe there's a requirement, and that's the assumption in this protocol, that there can be and often will be a separate discovery provider. Once you say that, the question is, all right, well, how many discovery providers are there? Are there one? Are there more? Are there like a dozen, or are there thousands? And in this proposal, it makes the assumption that there is more than one. It's probably like less than 10. It's not a large number, but it's greater than one. And they will largely be driven on geopolitical boundaries. So, I can imagine there's like a, in the US, there's two, in Europe, there's one, these kind of things. It's a small cardinality. And they have high trust, and they in fact exist only because we need a third-party trusted entity to mediate against the partially untrusted messaging providers. Those are that's the core requirement. Like if you don't agree with all that, then most of the rest of this protocol seems like way overkill. So I see people are in the queue. So let's go at it.
Yeah, I don't agree with that. In particular, I think the geopolitical thing is just like a non-starter. For like any number of logistical reasons. So, if the situation requires like each of the jurisdictions standing up their own thing, like we're never going to get there.
Sorry, no. I apologize. No, I'm not overreading that. The better way to delete bullet one and say, I believe there will be a number of discovery providers greater than one. And there's a few reasons for that. What's that?
Yeah. So why?
Okay, so this is good. So like it gets back to, there is a geopolitical aspect to it, which is like, I thought about the just one case. In fact, the original version of the protocol had it just one. And the problem is it requires like everyone to agree that I'm going to upload my PII, personal identifying information, right? My email addresses and phone numbers and mappings to their service providers to some entity. And the belief that we would be able to align on a singular entity, we being like the internet, align on a single entity that everyone will trust for that seem minimal, especially in light of like a lot of this GDPR regulations where they don't want storage of this PII to have to be outside of boundaries. Made me think that we're going to end up in a situation there we're going to have more than one, and that's the way in which I think about geopolitical.
Well, I think this partly gets back to this question that we were discussing last time, which is what is the privacy situation or security situation around this data, right? Namely, is this data inherently public or is the data inherently private? And if the data is inherently public, then like it matters a lot less where it's uploaded to, right?
I'm afraid I don't agree with that, and at least I don't think that's what GDPR says either. Like I don't think GDPR talks about whether the data is public or private. When you talk about personal identifiable information, it's information that's about a person of human nature, and in this case, it is that an email address and a mobile phone number count as PI, and it's storing information, which is who is their provider. We have others like Alyssa who are far deeper experts on GDPR than I am, but like that, my read is that it is not about the public or private nature of the data. It's just about whether the data is about a person.
So, sorry, I'm talking about public or private in a technical sense, not a social sense. What I mean to say is it a problem for me to have a copy of this database? Namely, like, so again, this goes back to like the straw man that I proposed last time, which is like the data is posted on Cloudflare. Anybody can download it, and the whole thing if you want. And I think that if you think that is if we're trying to prevent that, then we actually have to ask what we're doing to prevent it. And if we're not trying to prevent it, then we should admit we're not trying to prevent it. And like it's a whole different class of designs, right? And and I guess to cut to the chase, my thesis is actually can't be prevented in any meaningful way. So because like rate limiting is not going to work. And I'm happy to go into some detail if you want, but like. So then maybe that's not maybe for GDPR it's not required. If pretending to prevent it, maybe it's actually required rather than actually preventing it. But like I do think I think we need to start with what we're trying to accomplish here. If we're trying to accomplish here is access control in this information, then that is something. Then the question is, what is the access control requirement that we're trying to enforce?
Yeah. Yeah, got it. So I think again, what this document is assuming, and this is not well spelled out in the slide, so I apologize for that, but what I think it's assuming is that it is not acceptable to store the data in a singular place, that there are going to be requirements that limit where the data can be stored. So that's assumption number one. So that means, like, for me, like storing it all in Cloudflare, this assumes that that's not okay. The second assumption that I'm making is, yeah, that this data is at least somewhat sensitive. At least it's sensitive in its aggregate, meaning information like, oh, isn't that funny? I just learned exactly how many users each messaging provider on the planet has. That, like a normal SaaS provider, like my exact count of my customer base is considered sensitive information. So that information is not something I want anyone to be able to get. And so the system, of course, some amount of access to this data as a whole is necessary for the protocol to work. So what this is trying to do is limit, it says, I want to protect the data in aggregate and just give access to query response, because the aggregate data does actually have privacy properties too. That's the assumption.
Okay, I mean, so like, yeah, maybe it's not helpful to do here, but I guess, like, I mean, I do think we need to engage with this problem that scraping is essentially hard to prevent, right? Namely, like, so I think just like to say what I said on the list the other day, right, is like any plausible provider of like moderate size is actually going to be querying almost the entire database at the end of the day. We're querying almost into at least of cardinality somewhere in the entire database, right? If you operate 100 million users, and each of those has 100 adjacencies, you have to query 10 billion records, basically, right? And now you may know that there may be about overlap, but nobody else knows that, right? And so, like, the bottom line is any plausible provider is actually going to have access to the entire database at the end of the day, in Oracle form. And so, unless you can tell me how to prevent that, I think, like, that the problem, then the situation is actually like, then like the mechanics of trying to like conceal it from the big provider is actually not very helpful.
Okay. Well, again, in the model I was proposing here, I was trying to solve that through rate limiting. Again, we can have an argument.
This is what they're supposed to do, right? My point is, if I have 100 million users and I have and I want to build the adjacency table for all of them, then I have to query for all their adjacencies. And that means I have to do 10 billion plus or minus queries, right? And so that means that even that they're within the rate limits, I'm going to actually be querying for essentially the entire database. But even if I have Oracle access, so even if you have perfect information in the rate limits, it's just a legitimate operation to query for basically the entire database. And so at that point, why not just give them the entire database?
Maybe I'm not understanding you, but I'm thinking of the following use case. So we have a huge provider like WhatsApp that has like 1 billion records, say.
Yeah.
And a small provider called, like, I want a copy of this database and I'm a bad guy.com. Who sets up a bad and they have 10 users. So let's run with
that. I agree with. What I'm saying is, like, you're not going to be able to stop Apple from building a list of all of Google of all WhatsApp users.
I think that's very likely. Yes, that I agree. I agree that probably will not happen.
Any moderately sized provider, say 10 to 100 million users, right? Well, but
yeah. Well, we've got like 3 of them, so I'm not overly worried.
Okay, good. Okay, but I agree with you. I think we can stop. Like, you personally for stripping the entire database. That I think we can do.
Okay, great. That's what's partly this is trying to solve. Thank you.
So a couple of things. One is that I really think it would be helpful to distinguish between the properties of the databases and the properties of the accesses to the databases. And honestly, I find the GDPR, the data localization mandates, all of this stuff is like, it's totally a sideshow because it relates to like the governance around the databases themselves. We have lots of distributed services on the internet. The way that each operator of each service manages their GDPR compliance is like up to them. We don't talk about it in the IETF. It's not very helpful from a protocol perspective as a normal matter. And I think that's very true here. Whereas like this question about who gets to know what about each access to each database, that's what we really need to come to agreement on. And we talked about it a little bit in the Google presentation. I think we made some progress on that, which is like everybody, I think, agrees that if Alice is on service A and Bob is on service B, then service A gets to know that Alice wants to contact some generic understanding of Bob's identity, and Bob himself gets to know that and service B gets to know that Alice is contacting Bob. And then there's a bunch of other services that we do not want to have know that Alice is trying to sort out Bob's identity. So like that part is interesting, and we need to understand the identities in the all the protocol machinery. But this, like, where do the databases live and who controls where the databases live, I don't think is very useful for us. I also want to come back to this question, which you sort of pointed out.
Can I ask a question in response, Alyssa? So does that mean, like, so for me, it's a reason why I don't think a model wherein there's one discovery provider that has all of the data is viable. Now, maybe it's not viable for other reasons, but if unless someone thinks that's the solution, then I'm happy to never talk about GDPR again. Do you think that
I guess I want to come at it from the other end, because I feel that there's a strong assumption in some of the other proposals that that the applications providers will be one type of discovery provider. Like some applications providers will also be providing discovery services.
Yes.
And like, if you agree with that, then we don't have one. We have numerous. So we don't need to talk about whether we have one or not, because we already are assuming we're going to have multiple.
Okay, then I'm good.
So
I'm good. I think so.
That's where I was getting to. So then my question for you is, I think kind of the reverse of what you asked Giles, which is if you also feel that it's important to accommodate discovery services that are operated by entities outside of application providers. So do we have independent discovery services and application provider discovery services, or do we only have the ones that are run by the application providers?
It is my belief that we have to support both models.
Okay, good to know. Thanks.
Jonathan, if I could fast follow on that just real quick, could you expand on why you think we need discovery providers who are not application providers?
Yes, because of the trust problem. Because I'm worried about this, this use case I just described, which is a lot of smaller messaging providers. And those can be small consumer apps, but more importantly, they can be enterprises. They can be UCAS, CCAS, CPaaS providers. And so once you start, and this is all in my requirements document, it's why I went to so much trouble to outline this, because I think it's something that's not something we're all aligned on. So I do think there's a world in which the cardinality of those is in the hundreds. And once you have something with a cardinality of hundreds, and they include enterprises, I think you will have malicious players. And so a big problem I was trying to solve for is, how do you derive trustable mappings when you have some providers who you don't trust? And one of the ways you do that is you separate them. So you say, okay, well, I'm going to solve it by having a separate discovery provider, and that discovery provider actually validates the mapping themselves because they don't trust the messaging provider to do it. And this is sort of covered in the slides that are to come. Alyssa, are you still first in queue, or no? Okay, Watson.
Hello. So I think I maybe not following the part where you're saying, because we have all these providers, we need to separate out the discovery. I mean, I think really that's not a problem statement. That's a solution. And the problem is to get the property Alyssa outlined. If Alice wants to talk to Bob, the only people who learn anything are Alice's service provider and Bob's service provider. And Alice's service provider knows that Alice wants to talk to someone at service provider B, and service provider B knows that Alice wants to talk to Bob. And that's sort of the minimum amount of information you need if you want to do things like offline status and deliver when Bob comes back, because that's inherent to the nature of the communication. So if we are getting that property, why do we even need to have the discussion about limiting the discovery provider? I mean, it seems to me like actually this is saying, no, the discovery providers are not being are have too much power here. You can't make everyone one. And then the validation. So I think the previous case tossed it out to the CA. Sort of said, sweep it under the rug, shove it to the CA. I'm glad that you're not doing that. But that seems sort of that question of how do you validate the mappings seems not. We don't have to validate the mappings. You sign them by some key. It's not really connected to how you find them in the first place, which I think that's sort of at the root of my confusion with what you're talking about.
Yeah. So to me, the problem is, public key crypto doesn't magically solve the problem I'm worried about, which is how do you trust let's go back to your framework. Also, we said like what I care about is like only provider B should see that a user in provider A wants to talk to a user in provider B. This makes an assumption that the user actually is a customer of provider B. So again, the use case I'm worried about preventing is malicious provider that claims a particular phone number is a user of their services when that user is in fact not a user of those services. And that malicious provider in your model would therefore be able to see anytime someone else wanted to talk to user B, they would see a query, and that gives them access to information. So let me give a concrete use case. So let's say I'm a bad guy messaging provider, and my objective is to like find out whether there are people talking to a known target. So I want to go after the CEO of some big company. Tim, let's pick on Tim Cook. So I want to attack Tim Cook by learning more about his social graph. So I set up a fake messaging provider. I find out Tim Cook's phone number. I claim that I own it. Now I am going to, in many protocol designs, get queries to discover this phone number, and I can reply, yes, it's me. That I am a provider for that phone number, and then at the very least get connection requests and other things and other traffic I don't want them to see. That malicious attacker can see. That is the core attack I'm worried about preventing.
I guess I also respond to that. I'm next in the queue. I don't see how you solve that without having some kind of like allow list or standard criteria for participating in the interop system.
Great. So that's a good lead into the slides which explain my solution. So
okay. But I did have another. That was a response to previous commenter, to Watson, sorry. And but my other comment was, I agree that we need multiple mapping resolvers, but not because of GDPR. I think that the data that we're talking about here is there is an account with a phone number X, and that data is already public, as we've said a few times. So that's not. I don't think that's a good reason for multiple providers. But the reason is that, like as has already been said, number one, there are multiple service providers, but also I do agree that we probably need at least the possibility of a discovery provider who is not one of the service providers. And I think it would be naive to assume that we have like only large players who can run a discovery service provider, and that the total size of our system is going to be limited to tens or even hundreds of providers. I think we should design it to be arbitrarily large.
Yep.
Because you never know how it's going to be used in the future, and you're limiting it otherwise.
Yeah. If we're on the same page about like there being more than one provider and that the messaging provider might be the app provider, they might not be the app provider. Like, if no one here thinks that cardinality of one is a solution, I'm happy to never talk about GDPR again. I think it's one reason why you can't have just one. So, but we have Richard who shaded his no, so he's here to argue for one discovery provider. No.
No, that was shaking my head agreeing with you. There is no world in which a single.
This is no, this is yes is how you agree. Yes, thank you, Richard.
Have you ever tried shaking your head saying yes? It's challenging.
Do the ambiguous head nod. I don't know. Okay, keep.
So I encourage you to go a little further on the point I raised before. I think you and I agree on cardinality, and we agree on the shape of the trust problem. So I agree that there's going to be bazillions of these providers once you get enterprises in on the game, and I agree that there's going to be shady providers that you don't know how to trust, and they're going to need some other trust anchor. I think where we depart is how that reflects in the system for distributing the information.
Yeah.
So I think I'm pretty much on the same page Watson is. And I wrote up a whole scheme on this to the mailing list after the last interim, where like, if you separate the authentication from the distribution of the information, you can distribute the information however you want, as long as you ultimately verify the information you get back, however you got it. This is actually how the web works, right? Like, you don't care how you got your DNS information. You trust whatever resolver you walk up to on the street. And then when you finally make an HTTP or a quick connection, I guess, to the web server, like, you check its certificate and you verify that some trusted party vetted their identity. So like, I don't think it's, the shape might be slightly different here, but I think that overall principle that there are some authorities who vet the mappings. Some of those authorities are probably going to be the big providers who are trusted to vet their own mappings, and some of them will be third parties who do the vettings on top of on behalf of the shady providers. But I think we can put that to an identity problem and not necessarily an information distribution problem.
Okay. I'm not sure how that doesn't agree with my proposal. So maybe that's a good time to get into it.
I think what I'm catching on in this slide is mapping resolvers, because what you care about, the things that need to be, it separates your information flows from your trust boundaries, right? Because you can store information wherever. If your database needs to be, EU local, sure, great, but you could still have some, Kazakh authority who's vetted your stuff, or some US, some global scale authority. So yeah, I think it's that the idea that we need, and I think that's where I was thinking is this idea. What I'm questioning is like the need for people involved in the distribution chain who are not the provider, the application providers, right? So like, if I'm trying to talk to someone who claims to be from shady enterprise, assuming we have some PIR nonsense to protect what I'm asking for, like, I can get identity from shady enterprise, as if it's vetted by someone else, but I can physically get it from them if it comes with proof that someone else did.
Yeah.
Right. So it's really that provider thing and the mechanics of the information distribution that they don't need to be tied to this trustee question.
Perhaps, but then it becomes a scale problem, right? So again, the assumption here is that if there's just a dozen discovery providers, like hard coding them to know where to go to find, this is not a problem. When I have to know about every messaging provider and fork my query to all of them to find out what they think, and then again validate the mapping that they return, like, that just seems harder. So since you already have a central, for a bunch of messaging providers, they'll rely on a discovery provider that's different. This is all the smaller and partially trusted guys. Why not have them distribute the data that they're authoritative for? What's the benefit of introducing complexity to have that distributed, that discovery provider sign the mapping, give it back to the messaging provider, and then have the messaging providers have this massive fan out between them? Like, just it was solving that more nuts and bolts problem. That's why.
Okay. All right.
Okay. All right. Why don't we jump back to the slides? Just again, I think it's useful at least for folks to understand what I'm proposing, if you don't agree with it. Next slide. All right, so I think we've sort of beaten this. The foundational model is there's multiple discovery providers, there's lots of app providers, there's tons of users. Nothing in this system ever has the users talk to the discovery providers, users talk to app providers, only in this model. Next slide. I think this is the one thing I actually do think we agree on. So next slide. Just to explain the simple version, when it turns out that my app provider talks to a discovery provider called glass provider. So here's like the basic protocol. The simple version of the protocol, there's sort of a few different pieces to it, is a simple query response. It's like really dumb. It's not complicated. Consumer says, hey, I want to talk to this guy with this phone number. Sends to their app provider. Their app provider has the right of first refusal. It has the right to say, okay, no, this is already a Facebook Messenger user or a WhatsApp user. I think that's an important requirement. We can't remove from the app provider their ability to manage messaging between their own users. So this is another reason why I tend to think any solution that has the consumers talking directly to other providers is a complete non-starter. But the app provider gets to say, okay, great, they want to talk to this number. I don't know what this is, not one of my users. All right, let me check. So app provider here would say WhatsApp, and step 3 goes to their glass provider and says, hey, what do I do with this phone number? And it turns out that that phone number happens to be, in this case, cached or known by the GLaDOS provider, perhaps because that GLaDOS provider supports another app provider that has that number, and it just returns a mapping. So the GLaDOS protocol is worried about the on the wire between the app provider and the GLaDOS provider. Ecker.
So I'm going to stipulate for the moment that the app provider should get to control the priority of answers. Though I'm not sure I believe that, but why does it have to be reified on the wire like this?
What does it have to what?
Be reified on the wire like this. So let me give you a so imagine imagine the sort of the naive fan out version, which the client talks to every single app provider and says, do you know about this? And imagine that's secure with PIRs, you don't have to worry about blah blah blah. And then the client picks the top result. To the extent to which the client is controlled by the app provider, there's the same thing as that has the same priority list you described here. Why do you assume that it has to be reified in the protocol merely rather than be a client policy?
I guess I think there's a trust question. Again, it's wrapped up in the same discussion we've had over and over, meaning like, will iMessage be willing to service queries from a application, from WhatsApp, from a user who can't even authenticate? Like these would have to be all unauthenticated queries, and I just think that's unlikely.
Well, that may be true, but that's a different statement from the one you made earlier, which was about
right. Second, okay, I'll get to the second. The second reason is the sort of what I almost call like the fundamental theorem of MIMI. The fundamental theorem of MIMI is we're designing a weird protocol where the people who are to implement this protocol don't really want to implement this protocol, and the only reason they're really doing it is because the EU is making them do it. So in that model, you want to maximize the acceptability of the protocol. And to me, like I'm making an assumption that we're not going to change the way the system works for these providers today. Like you do exactly what you're doing. The only thing that changes is the flow for when they want to talk to someone outside. That's the only thing we're asking you to change. And we're not even asking you to change, introduce new trust. Like this, to me, it's about minimizing disruptiveness of architectural change to those providers. That's more the reason I'm suggesting that.
Okay, so I think that I'm more persuaded by. I just think that if you want policy enforcement, they control the software. They can do anything they want, right?
Fair enough. Yeah. They could. You're right. They could. Yeah. Okay.
Okay. Thanks.
All right, let's keep trucking, because now we get to the interesting stuff. Next slide. So, all right, here's going to be, so there's three pieces to this protocol. Piece number one was the one we just looked at, which is a simple query client server query protocol. That's like so boring, whatever. The second part is more interesting. So, and I think what someone had asked this question, like I forget who was, or maybe it was Giles was like, hey, like, how do you solve this problem where you have untrusted application providers, but then you somehow magically trust the discovery provider? This is the proposal. So again, let's look at a use case here. Okay, so let's say the user is using WhatsApp. The application provider is the WhatsApp backend. So user is a mobile device. AP is the application provider. WhatsApp's backend, and there's a global provider, the GLaDOS provider GP. Let's assume the use case of a new user signs up for WhatsApp. So they download the app from the App Store. They access the app, and there's a normal onboarding flow that every one of these applications today provides, which asks the user to enter their email or phone number. The user goes into the mobile phone, types in their phone number. So that's the SII that basically gets sent from the user's mobile device to the AP. Today, the application provider would go and verify that number by asking Twilio to send an SMS, or whomever your preferred SMS provider is. It would include a code. The user would, enter the code back and what have you. So what this proposal is suggesting is, let's in essence introduce a new entity, the GP, to sort of do that, where the application provider would say to the GP, hey, they'll create a new user ID, and that creates it locally, and then it'll over the wire. Now the AP talks to the GP and says, hey, create a mapping between this user ID, think of it as a random number, and the SSII, which is the phone number, right? The GP's got to trust that this is valid. That's the hard part. And it does it by having the GP perform that mobile number verification. It actually sends the SMS with the code. The code is entered by the user into their mobile app. The AP passes the validation code back to the GP. The GP compares them, and it says, okay, this makes sense. I've now gotten verification that this user ID is in fact associated with this phone number, and then it stores the mapping and considers it registered. And it's sort of really similar to how it's done today between many of these APs who depend on the likes of Twilio and Nexmo and others to do this mobile number verification. But now the GP stores the mapping, and if you trust the GP to do this properly, the mapping can be trusted even if the AP is not. So again, if the AP was a malicious provider claiming, let's go back to the use case I was all bent out of shape about. Let's say the AP was like, I'm a bad guy.com, and they, managed to have Tim Cook's mobile phone number. They would initiate this flow, create a unique ID, ask the GP to create a mapping. The GP would send a text to Tim Cook's phone and be like, I don't know what this is, and it gets ignored. Mapping deleted. Now, I'm sure we can debate about the trustworthiness of mobile number verification to trust these user identity verifications. It's widely used on the internet. This doesn't change that. You either believe it or you don't, but it puts it in the hands of the GP to trust the mapping, and it does, to the degree you believe in mobile number verification, it does prevent the attack that I have been all wound up about. I'm going to pause there and see if there's questions on this one. I'm sure there are.
Oh, Watson, so it seems that this mapping that's being verified is just the mapping of the SII to provider. There's no place where you're adding in the user's public key to bootstrap their best relationship.
Yes, that's right. This design makes an assumption that there's a separation in the protocol layer between the discovery process and the sort of identity, so the public key distribution process. Now, you can imagine in this case the GP, either the AP or the GP could actually provide the public key. But you're right. In this design, Watson, it considers the keying, public key distribution and distribution as a separate problem. This is strictly trying to solve the discovery problem.
Right, but then you need to go have the user do a separate validation that their phone number can be connected to a public key if you separate them out.
Yeah.
That doesn't seem
I
very
think
fun.
it's fair feedback. Like I mean, you might argue, hey, you could say, hey, Jonathan, you dum-dum, like you missed the obvious thing. Why don't you have the GP issue a certificate while you're at it? That's probably good feedback, actually. It's a good idea. I mean, yeah. Becker?
Yeah, so I fear I'm just like echoing Richard Barnes here, but I feel like you're really like conflating two things. One is authenticating the ownership of the number, and then this discovery thing. And like we already have like a worked example of this, which is like you issue a credential, and like I don't really understand why we're gluing those together. And like and I think it's like not clear, like I'm just like not really following why these two concepts should be glued together. And
Sorry, the two things being what, Ecker?
Yeah, validating that the given entity has the right to identifier, and then disseminating that information. And as Giles points out, like really what you want to do is validate that the identifier maps to the person, not to the provider, and this conflates those as well.
Yeah. So what you're doing with the validation process there is mapping the identifier to the person, which I call a meat bag, but the problem that we're trying to solve is mapping the identifier to a service provider.
Right, which does in this. Sorry, this does that.
Well, not really.
So this allows the GP to know definitively that the SAI is associated with AP. This app provider. That's what this flow does.
I'm not sure I'm following that, because when I respond with the validation code, I'm proving that Giles owns the phone number. I'm not proving that I have an account with APX, or maybe I'm missing.
Well, because you got Giles, the user, entered the code, and it's such a way that it was obtained by AP, which means you were using their application. How if you were using if you never were a user of AP would be unable to obtain the validation code. In this flow, the AP does not get the validation code from the GP. The only way AP can learn the validation code, the short, the 6-digit code sent in the SMS, is if the user provided it to the AP.
If I may, let me try to motivate, but I think this is actually a bad design, not just a necessary design, which is that that the GP in this case is going to actually allow some providers to just assert identities for streamline.
To what?
Just simply assert identities. When WhatsApp shows up and they say we own this number, the GP should just accept that.
I agree.
And when and as you say, when like Jonathan Rosenberg's thing shows up, they should not just accept that, right? And but if we start from that premise, then like it's much more natural to separate out to have all these people have the thing that causes the GP to accept your assertion is their certificate, and then the GP has some set of CAs it trusts, and so WhatsApp is one of those CAs, and Jonathan Rosenberg is not. So you have to go make a deal with some CA to sign your thing. But none of this gets glued into the GP's mechanics, which just takes the thing and it takes a signed object. And so in this case,
it reduces it to a previously unsolved problem, which is like, how do you know them? How do I verify the ownership of a phone number? How do you generate a certificate? But phone number. That's like we've proven this problem unsolvable over and over again.
But the CA does exactly the validation you're discussing. But what I'm saying is, why are you making the GP a CA? You just made the GP a CA for no reason. And it's actually and the mechanics of running a CA are actually very different than the mechanics of running a global directory service. And so why would you want to set this together?
Okay.
Especially
I think-
especially given that like right now all the providers actually are learning CS anyway, and we can live that way for a while, right?
Yeah.
I think we're agreeing that we need that functionality, and I understand what you're proposing now. I think it makes sense, but I think we're just saying separate out GP and CA functionality.
Yeah, I think I understand. I do understand your comment on that, Ecker, that you are correct. This could be alternatively solved by having GPBCA produce a certificate, and then through some other means, we are basically distributing these certificates. So, and I combine them just for reduction of complexity of players. But I think it's it is a valid design to have them separated. I don't dispute that. I think Liz is going to tell me we're out of time.
Yeah,
What do you even get to
sorry.
the most exciting part of this? The Bloom filter routing protocol.
It seems like we could spend an infinite amount of time talking about discovery. And we will have more time in Prague, so that's good. But I do think we made progress on the requirements though today. Like I feel like we made some incremental moves there in terms of getting agreement on the cardinality and the social graph privacy. So that's good. We have another interim next week where we're going to, I think, be going back to the design team on the other track. But then the draft deadline is only a couple days after that. It's in basically 2 weeks from now. So it would be really great to get updates to these drafts, kind of reflecting the discussion thus far and providing the clarifications discussed, and also like maybe starting to think about whether we're actually all kind of talking about the same solution with slightly different properties, or if these actually are like completely different protocol entities and interactions. I feel like there's a little bit of convergence going on. So if folks can think about how you update your drafts that way, and please use the list for individual issue discussion as well. All right, I think we're going to call it. Thanks, everybody.